Okay, so for doing calculations for experiment 10, which is thermodynamics of dissolution for borax, you hopefully recorded your mass that you measured out of sodium carbonate and then your titration volumes here. So I just have these initial and final, and to do the total volume, again, you're just going to subtract. So I'm just going to fill those in here. As you can see, all of my volumes are within a mil of each other, so they should be fairly precise. For the temperatures, I have the temperatures of the 6 water baths recorded, and then the volumes here. Again, I'm just going to fill those values in, and that was just obtained by subtraction. Okay, so I'm going to go to calculations for, this is just for trial 1 to determine the concentration of HCl. So this is for the standardization of HCl. So you're going to start with moles, finding the moles of carbonate, sodium carbonate. So for the first trial, again, that was 0.183 grams of sodium carbonate, and to get that into moles, I'm just going to divide by the molecular mass of sodium carbonate, which is 105.99, and that should be about 0.100155 moles of Na2CO3. And then if you look at the equation in the lab manual, we have carbonate plus 2H plus gives you water and CO2. So for one carbonate, there's 2 H pluses. So for 0.00155 moles of sodium carbonate, that will be times 2, 0.00310 moles of HCl. So again, this is a 1:2 ratio, 1 mole of sodium carbonate to 2 moles of H plus, and that's from the equation here. So that's going to be 0.00310 moles of HCl. So to determine the concentration of HCl, we're taking the 0.00310 moles of HCl, and then you're going to divide that by the volume that was titrated in liters. Okay, so for trial 1, I had 13.23. So that's mils. So 0.01323 liters. So my concentration of HCl for trial on is 234.3 moles per liter, or capital M. So you want to do this for all 3 of your sodium carbonate trials with HCl, and then find the average as well as the RSD. To get to the molar solubility, this is for trial 1. You have moles of the borax equals the volume of HCl titrated times the concentration. So this is the concentration of HCl that you just determined on the last page, and use the average. And then that's going to be times 1 mole of borax over 2 moles of HCl. So again, to find the concentration, we have moles of borax over the 0.00500 liters. Fill in my values here. So the volume of HCl I used for the first trial, which was my cold one, was 0.00636 mils or liters, and my concentration average was 0.2174 moles per liter of HCl, and that is times 1 mole of, I'm just going to write borax, over 2 moles HCl. Should have get 6.913 times 10 to the negative 4 moles of borax. So I'm just going to plug that in, put that over here. So the moles of borax, I'm just going to plug that value down to here and divide it by 0.005. So this ends up being 0.1382 is the concentration of borax, which is also equal to the molar solubility. So you would need to do this for each of the temperatures because the volume that you're using of HCl is going to differ. So the molar solubility of each of your titrations that you did will vary depending on the temperature. And that's one of the properties that you're looking at here. So again, this is the concentration of B4O5 OH4 2 minus. Part of the calculations is determining the solubility product, which is the KSP. So the KSP of borax is 4 times the concentration of borax cubed. So we have 4 times 1382 cubed. And then you just want to remember your order of operations. So this gets cubed and then multiplied by 4. So you should get 0.01057-ish. Okay, so that's going to be your KSP. So to do your graph, then you're going to take the natural log of all those. So it's going to be, your graph will be natural log of KSP times 1 over T. So you need to convert all of your temperatures to Kelvin, do the natural log, and then do the graph. And you're going to get a slope of your graph. So here is the graph, and I'll do another video to help you out with the spreadsheet here and the graphing. And it can also calculate the natural log and temperature for you as well if you want. So this is my graph. It looks fairly linear. This is my slope. So if you look at the in the lab manual here, the slope is equal to negative delta H naught over R. So this will be negative 4507.2. So that's the slope. And then for the y-intercept, that's negative delta S over R. So the y-intercept is 11.623. Okay, so you can use this equation. If you solve for the negative delta H, you get the slope times R. So your slope is negative 4507.2, and you're going to multiply it times 8.314, and that will get you your value for negative delta H, which will be negative 37471.2. And then for delta S equals R, your y-intercept 11.623 times 8.314 equals S, which should be 96.63. And then you can use these two values and plug it in for delta G. So it's negative delta H 37471.2 minus, now you just plug in your T delta S, 298K. This is at room temperature. So 298 times the S, which is 96.63. So delta G free energy for this is going to be negative 66268. And that is just for the one. Well, this is the calculations up here for molar solubility is for trial 1. So again, you need to do them for all 6 of your trials. And then this is how you would calculate the rest of it. And then I will do a separate video here to do the set up your calculations in Excel.